Hi everyone, welcome to second video of deep learning. In this video, we will be discussing about how to construct CNN model for given image classification task. If you want to construct CNN model for a given task, let us say you have an image classification task, okay, which classifies images into, let us say, two classes, cat versus dog. Okay, in that case, what you can do, you need a CNN model. So there are two ways to construct. Method one, if you look at the method one, so here you can build it from the scratch. You need to, construct the CNN model for your given application. So when I say build it from the scratch, that means CNN architecture, if you see, it will have different layers. Convolution layer is very important because it extracts the features of an image, and then you have pooling layers, you have fully connected layers at the end. So if you're building it from the scratch, that means you need to identify how many convolutional layers are required and dimension of various filters, pooling layer, fully connected layer. So this is going to be a tedious work. Unless you have good knowledge about CNN, you will not be able to design this. Okay, so it's going to be a complex task. And the second thing is you will have to train all these layers so that their weight will be optimized for given task. All these, let us say, convolution layer, fully connected layers, these two layers will have some parameters. They will have some coefficients. So these coefficient values have to be computed during training process. Since number of parameters are more, so it takes more time for training. So that is one thing. Training the parameters of entire model takes more time. And the next thing is optimization is very complex task. Getting high accuracy is very difficult unless you have optimum number of layers, etc. Okay, so that is one thing. The second thing, there is another alternate way to construct a CNN model for your task. So what you can do, you can go for what is called as transfer learning. In transfer learning, what you do is you don't have to train the entire model. You don't have to construct, so all these convolution layers, etc. So what we do is feature extraction part of the CNN model will not be constructed. You can retain it as it is, and you will be using a pre-trained CNN model. That means the CNN model already which exists. Okay, so you can directly use it. But the only thing is that the classification part has to be modified. Originally, that CNN model has been trained for maybe 1000 classes, 1000 images, but in your case only two classes, cat versus dog. Okay, so that prediction part, the last part or classification part has to be modified. So that is one thing. And since you are using the best pre-trained CNN model, which has already shown a good accuracy, you can expect more accuracy when you design using this method. So this is called as a transfer learning. It's also called as a retraining. This slide shows the second method of constructing, which I just explained, which is called transfer learning. In the case of transfer learning, so what we do is, let us say if this is the pre-trained CNN model, it has got feature extraction section and classification section. Feature extraction section will have all the convolutional layers which extract the image features like edges, corners, etc. So this part of CNN extract all the important features of an image, whereas this part is responsible for giving specific output for a given image. If there are 1000 images are there, then different outputs. Let us say the first image, let us say there's an image of a bird. Okay, so output may be 0. There is orange image, output may be 1. That means this section is responsible for producing the correct output or the specific output for an image. Okay, so these are the two parts that you have. Now Since you are using, you want to construct a CNN model for the same image classification task, okay, and the objects or the images which so you have in your data set are similar to one for which it was trained earlier. So what you can do is you don't have to retrain this part, feature extraction part. So you can directly use it while designing CNN model for your application. Only this part needs to be changed. That means the classifier part needs to be changed. So I have shown in blue color. That means this convolutional layer weights or parameters, they need not be changed, or you don't have to train feature extraction part. You just have to modify this classification part. You can remove the older layers, whatever was there, and replace it with new one. The reason is earlier there were 1000 different outputs for 1000 different image classes. Right now, for your application, you have only two images, two different images you have. One is a dog, cat. So only two outputs or labels are required. Okay, so this part has to be changed. So this is much easier because the parameters which have to be trained are less. So it takes less time in training. And one more thing is, since you are using already pre-trained CNN model which has already shown a good result, so you will also get a good accuracy. So this is called as a transfer learning, and this the layer which is present here, it's called as a transfer layer. So you are just modifying that particular layer. You are not touching the convolutional layers, etc. And there is another way also. There is this is transfer learning. There is another way of retraining it. That's called as a fine tuning. In fine tuning, what you do first, perform transfer learning as it is, as I explained just now. Okay. After that, you can tweak the values of feature extraction part. You can fine tune them, okay, to get a little bit to improve the accuracy. So that you can do. In case of transfer learning, you don't alter the weights of feature extraction part at all. In case of fine tuning, you perform transfer learning, try to get a good accuracy. But if you want to improve the accuracy, a little bit more, then you can tweak the values of these feature extraction part or convolutional layers, or you can fine tune them. So then it is called as the fine tuning. So transfer learning and fine tuning, these two are the method which can be used during retraining procedure. And so as a beginner, you can try using this second method of retraining it. We understood that the second method of designing CNN model is easier. That means you retrain the pre-trained CNN model for your task. And this slide shows the names of few pre-trained CNN models like Inception, AlexNet, VGGNet. These are all the pre-trained CNN models which are constructed by different companies and universities. Inception is developed by Google, and all these pre-trained CNN models have given a very good accuracy when it was trained on a data set called as ImageNet dataset. ImageNet dataset of thousands of image classes, nearly 20,000 image classes. But for this pre-trained CNN model training, only 1,000 object classes have been used. So these CNN models can recognize, these 1,000 image classes with high accuracy. And some of the images which these pre-trained CNN model can classify are shown here. So you have different categories, like you have birds, animals, fruits, sports equipments, etc. So what you can do is, in order to start building your CNN model, you need to pick one of these pre-trained CNN model. Let us say Inception. And Inception, again, it will have several versions. You started with version 1, V1, then V2, V3, and similarly you have V4 version. And similarly, if you look at VGG net, you will have several versions here. But there is a slight difference in the architecture and number of parameters. Some CNN models will have a very complex architecture, more number of parameters, etc. Okay, so theory about these CNN pre-trained CNN models we'll see maybe in the future videos. Once you identify pre-trained CNN model for your application, you need to start building them. That means you need to start coding. So you need a programming language. So Python is the best language because it has got several advantages, good user community, and very easy to import, modules for each and every task. So you can go for Python programming language, and it's easy to understand also. Now, you can't use Python alone to construct CNN model. You need some library of functions which are designed, so which are meant for constructing CNN models. So when you talk about these libraries, so frameworks are very, very important. So there are different frameworks which exist. So they can be used for constructing machine learning, models, deep learning models, etc. And I have listed a few of the frameworks which are designed by different companies. For example, you have TensorFlow, which is developed by Google. Similarly, you have Torch. Python version is PyTorch. And then you have similarly ML.NET, Keras, Theano. These are all frameworks. Frameworks are nothing but library of functions. You can import these libraries directly on your Python code, then you can use it. You can use these functions, TensorFlow functions, to construct CNN model. Okay, so that means you can, if you want to add any new layer, if you want to train the model, if you want to load the data set, so you can use the built-in functions which are there in the TensorFlow module. Okay, so when you use frameworks, your coding becomes very simpler. So this is very essential. Understanding different frameworks very, very important, and you will have to choose one of them for your application. So initially, to start with, in the next video we will choose TensorFlow as the framework, and we will choose Inception as the pre-trained CNN model, and you can start building a CNN model. Let us see what are the steps involved in retraining pre-trained CNN model. So step one is identifying the AI framework and pre-trained CNN model. Let us say TensorFlow we have chosen as framework, and Inception v3, and the programming language is Python. Step two is you have to install the necessary packages. So very important package is TensorFlow, and there are other supporting packages also. And then you need to install Python environment if it's a desktop environment. So what you can do is you can use Anaconda Python distribution, and through Anaconda distribution you will be able to install other packages like TensorFlow. So when you use Anaconda platform for installing the packages, all TensorFlow packages will be installed properly. So that is one thing. That's one advantage of having Anaconda. The second advantage of having Anaconda is you can create a virtual environment specifically for each project. When you're working on two different projects, then you can create two different virtual environment, and all the installations can be done within that virtual environment. So this will isolate the packages of these two projects. So that is one advantage of it. Performance of the CNN model depends on the data set also. So if you have a very good data set, then the performance also will be better. So data set consists of images of different classes. For example, if you're working on image classification to classify between, let us say, cat versus dog, then your data set will have plenty of images of cat and dog, so that can be used for training and validation. So that is step 4. Step 5, once the data set is ready, once uh, pre-trained CNN model and frameworks are identified, then you can use the framework to load the pre-trained CNN model, load the data set, and then you can start retraining the model using the image classes. Step 6, the last 6, you need to train it to optimize those parameters, and you need to validate to improve the accuracy, and finally once the model is ready, then you can test it using test images. So in the next video we will discuss about the installation steps, and after that we can start using the pre-trained model. So all the steps will be explained in the next video. Thank you.